Hello friends, this is Uncle Sam again. Previously we solved questions on homogeneous linear ODE. This time around we'll be treating a non-homogeneous linear ODE. Let me write that. Then don't forget we are doing second, this is not first order anymore, this second order. So let me write second order, um, second order linear and non-homogeneous homogeneous ODE. This is a sample here, y double prime plus p x y prime plus q x y equals what? Rx. This is a non-homogeneous because of this term. This term, any term that is different from the y term, it's either this will be a constant or it's like a function of x, maybe x squared, or you have exponential raised to power 2x, or anything just different from zero. If this is zero, then it is a homogeneous ODE. But since we have Rx as a value apart from zero, then it is a non-homogeneous ODE. And how do you solve this kind of question? It's by solving this separately. Um, okay, so let me just write. So your general solution will be in form of homogeneous solution plus the particular solution. So let me write this. Homogeneous solution plus your particular solution. How do you go about your homogeneous solution? You're going to assume this is zero, everything equals to zero, and you're going to solve just the way we solve our previous class. You're going to solve YH, where you're going to assume this is zero, and you get your arbitrary constants. You put it in the solution, you get your equation for YH. And how do you solve the particular solution? You solve the particular solution in ways of undetermined coefficients. So I'm going to give you a table now. If you have Rx, and let me put a choice for a particular solution. We call this method of undetermined coefficients. Yes, so I'll be writing values of the non-homogeneous side, and we'll be writing the particular solution for it. When you have k exponential gamma x, then your particular solution has to be constant exponential gamma x. So you have to make sure to solve for your a value and put it into the equation. So we're going to be solving questions on this, but I need to write some things down for you to know. So this is a table that you need to use in solving your particular solution. And also, if you have something like k x raised to power n, let's say your n is raised to power 4, for example, you start with a constant. The first term will be with the power of the term you have, n. Then you start reducing till you get to the constant. So for example, if you have raised to power 3 here, you have ax raised to power n plus b raised to power. Okay, so for example, if you have kx raised to power, let's say 3, then you start with ax raised to power 3 plus bx raised to power 2 plus cx raised to power 1, which is just x, plus d x raised to power 0, which is just d. So if you want to write equation for this, then you write b x raised to power n minus 1 plus c x raised to power n minus 2. Then you keep moving till you get to, let's say, d x raised to power, let's just say 1, then plus e x raised to power 0. Do you understand what I mean? So I just use this as an example for you to understand better. So I'll be removing this. So that's how to solve when you have a non-homogeneous value, which is in form of a power. And also, if you have a non-homogeneous value in form of k cos wx, your particular solution needs to be in both cos and sine. Please don't forget that. So you have a cos wx plus b sine wx. The same thing if you have, let's say, k sine wx, you can use the same value, or you can bring sine here, you can bring cos to the other side, any way you like it. But make sure you have your cosine, your cos value, and your sine value. So the same thing applies to this, right? So b sine wx. And if you want to write for k exponential alpha x cos omega x, you're going to write this first, e alpha x. Then you follow up with the same thing. The same thing if you have sine here. So you have a cos gamma t, or let's say no, omega x omega x plus b sine omega x. The same thing if you have sine. Let's say you have k e alpha x sine omega x. You have e alpha x a cos omega x plus b sine omega x. So that's the table. But there are other situations. There's a very funny situation that we call, I personally just call it annoying. I don't know if some textbook can also put it that way. Annoying twin case. So what do I mean by annoying twin case? This is a kind of situation if your particular solution gives duplicates. Oh, no, sorry. I need to remove this. If your particular solution duplicates a term from the complementary or let's call it homogeneous solution, then multiply by x or x squared. Let's say it can be x raised to power 32 until, so you need to raise the power until you get a linearly independent function. So what do we mean by that? If you get your yp, your particular solution, your yh rather, that's your homogeneous solution. If you get your yh, and let's say you get, let's say c1 x, right? Let's say e raised power, let's say x plus c2 x e raised power minus, let's say x again. Yeah, let's say something like this, x, and you won't be able to write a particular solution. You're supposed to write yp equals, a e raised to power. Okay, no, let's say this is a homogeneous solution, and let's say the question you're given is, let's say y prime prime plus y prime plus, equals, let's say 5e raised to power, or let's say 5e raised to power, let's say 5x e raised to power x, for example, which is almost same thing as, you know, which is almost same thing as one of these. You're supposed to write, let's say, e raised power, let's say x, but unfortunately you have this that is almost the same thing as this. You understand? So you have almost the same coefficient. So you need to put a value of x, you need to multiply by a value of x. But unfortunately, again, it's also aligning with this. So it will make it linearly independent function. Since they're also the same thing, you need to add another, multiply by another x, which is what? X squared. Then this will be your particular solution. So that's what we're talking about here. So it's very annoying because you need to actually check if there is no repeated particular solution, your particular solution with your or let me say your homogeneous value. Yeah, so you need to actually check, see if you need to multiply by x or multiply by x squared or multiply by x cubed. So you need to be very careful when you're trying to find a particular solution in your solving. We're going to solve a problem that will need you to check very well before you're able to put in your particular solution. Thank you very much. Have a lovely day.